Flashed face distortion effect. When you focus on the center of the cross, the faces on either side appear distorted and unsettling. This intriguing phenomenon was discovered accidentally, and researchers still don't fully understand its cause. Some theories suggest it's due to rapid peripheral visual processing, where our brain blends features from the faces, exaggerating their differences. If you knew this illusions, you win 1 point. Silencing effect. Looking at the center of this image, you notice the small balls changing colors. However, once the balls start rotating, they appear to maintain a consistent color. But if you concentrate carefully, you'll notice they're actually still changing colors just as they were when stationary. This occurs because motion causes our visual system to prioritize tracking movement over detecting color changes. If you knew this one, you get 2 points. Their dove illusion. Fix your eyes on the 4 central dots of this image. Similar to the afterimage illusion, this one uses the same mechanism, but with recognizable shapes and faces. If done correctly, you should now see an image of Jesus. This illusion exploits the persistence of vision, causing a temporary retention of visual stimuli. The negative colors of the initial image become a positive afterimage. Now, if you blink rapidly, you should see Jesus. You get 2 points if you knew this one. Hybrid image. From close-up, this image appears as Albert Einstein, while from a distance it transforms into Marilyn Monroe. This occurs because it merges the low spatial frequencies of one photo with the high frequencies of another, causing fine details to blur and reveal Monroe's face when viewed from afar. If you knew this one, you get 1 point. Kanizsa triangle. This image creates the illusion of a bright white triangle without any explicit lines or color changes. Many people perceive this imaginary triangle as brighter than the surrounding area and closer to them. This one is well known. If you didn't know it, you get -2 points. Kinetic depth effect. This spinning dancer appears to rotate in both directions due to the lack of clear depth cues. For example, her arms might seem to pass in front of her body or behind it, but when additional visual cues are added, you can clearly identify the direction of her rotation. This illusion emphasizes how crucial depth cues are in interpreting motion and spatial relationships. This one is famous. -1 if you didn't know it. Lilac chaser. This illusion unfolds in 3 stages. Initially, when you stare at the central cross, you see a gap rotating around the circle. Soon after, a green disc seems to replace this gap, spinning around the lilac discs. Finally, the lilac discs vanish entirely, leaving only a moving green disc on the gray background. This demonstrates how prolonged fixation causes neural adaptation, where specific color receptors become desensitized. You get 1 point if you knew it. Ebbinghaus illusion. Although the 2 orange circles are the same size, surrounding circles trick your perception into seeing the circle on the right as larger. This size distortion occurs due to context-dependent perception, known as the Ebbinghaus illusion, illustrating how our brain interprets size in relation to surrounding objects. This effect highlights how relative comparison rather than absolute measurement dominates visual perception. You get 1 point for knowing this one. Stroboscaping effect. Initially, this clock hand appears to move from right to left, but if it becomes briefly obscured repeatedly, you'll notice an altered perception. This phenomenon is related to the wagon wheel effect, causing helicopter and airplane propellers to appear stationary, slow-moving, or even spinning backward. It occurs due to the sampling frequency of our visual system, making moving objects appear to reverse or slow their apparent motion. You get 2 points if you knew this one. Line length illusion. These 2 lines appear different in length, yet they are exactly the same. This well-known Muller Lyer illusion exploits our depth perception cues, making lines with outward-pointing arrows appear longer than lines with inward-pointing arrows. This illusion vividly demonstrates how context and surroundings affect our judgment of length. This one was easy, -2 if you didn't know it. Hermann grid illusion. Gray blobs or ghost-like shapes seem to appear at the white intersections, but vanish when you look directly at them. This phenomenon occurs due to lateral inhibition in our visual system, where neurons responding to intersections become inhibited by surrounding activated cells. This one is famous. -1 if you didn't know it. Rubin's vase. Do you see a vase or 2 faces looking at each other? This image exemplifies how the brain distinguishes between figure and ground, with both interpretations interchangeable due to ambiguous cues. Rubin's vase clearly demonstrates the principle of bistable perception, where 2 equally plausible interpretations compete, revealing the dynamic and interpretive nature of visual processing. This one is also very famous. -2 if you didn't know it. Checker shadow illusion. Square A appears darker than square B despite both squares being the same color. This happens because your brain exaggerates contrast along edges to help with edge detection. This phenomenon shows how our visual system compensates for shading and lighting conditions, constantly adjusting our perception to maintain a consistent interpretation of objects despite changes in illumination and context. This is super famous. You lose 3 points if you didn't know it. Leaning tower illusion. Surprisingly, the tower on the right doesn't lean more than the one on the left. The images are identical, yet your perception says otherwise. This illusion occurs because our visual system judges the relationship between objects based on their surroundings. It highlights how perspective and context influence our spatial judgment, leading us to perceive an impossible tilt. You get 3 points for knowing this one. Hollow face illusion. A concave mask of a face seems convex, outward facing. This demonstrates the powerful influence of top-down knowledge on visual perception. Our brain strongly expects faces to be convex, so it overrides visual input indicating concavity. This illusion underscores the dominance of prior knowledge and experience in shaping our visual interpretation, often overriding the actual sensory information. You win 3 points if you knew this one. Stepping foot illusion. These two buses appear to move step by step across the image. But watch closely as the background's black and white stripes are removed. The bus's stepping motion disappears, revealing that they were actually moving smoothly all along. This illusion occurs due to high contrast backgrounds, which interfere with how our eyes track continuous motion, causing the brain to perceive movement as segmented steps. It showcases how background context dramatically influences visual motion perception. You win 2 points if you knew this one. Ponzo illusion. At first glance, the upper line seems notably longer than the bottom one, yet they're actually the exact same length. This illusion arises because our brains interpret the converging lines as depth cues, imagining the upper part as being farther away. By assuming the upper line is distant, our brain compensates and enlarges it visually. The Ponzo illusion cleverly exploits our instinctive tendency to interpret two-dimensional images as three-dimensional spaces. You win 1 point if you knew this one. Poggendorff illusion. In this image, it looks like the blue line is the continuation of the black line. Surprisingly, it's the red line that's actually aligned. This illusion occurs due to how our brain processes angles and interruptions. The obscuring shape and sharp edges disrupt our perception of continuity, causing misalignment. The Poggendorff illusion highlights how easily our visual system can be tricked by intersecting lines and obstructed viewpoints. You win 2 points if you knew this one. Wundt illusion. Are the two red lines straight or curved inward? Although they look distinctly bowed, they're completely straight and parallel. The distortion is caused by the background's radiating lines, which trick our eyes into perceiving a false curvature. Variations like the herring and orbison illusions demonstrate similar effects, proving how powerfully surrounding patterns influence our perception of straightness, often distorting reality based solely on context. You win 1 point if you knew this one. Rotating snakes illusion. At first glance, these colorful circles seem to rotate slowly, but they're completely stationary. This illusion is triggered by contrasting colors and repetitive patterns, which stimulate involuntary tiny eye movements called microsaccades. These subtle eye movements, combined with the specific arrangement of colors and shading, make our brains perceive continuous rotation. The rotating snakes illusion vividly demonstrates how sensitive and responsive our visual system is to patterns and contrast. You lose 1 point if you didn't know this one. Keep your eyes focused on the center of this moving image. When I tell you to look away, everything around you will seem like it's shifting, almost like it's breathing or gently pulsing. That's because your eyes get used to this kind of visual motion, and when you suddenly switch to something still, it takes them a moment to adjust. Now look around you. Did you see it? Please comment your score and don't forget to subscribe.